Hi, David. Can you hear me?
Yes.
Yeah, nice. So what questions do you have?
Hold up. Oh, okay. So about the domain and range, that's kind of
Okay. Which one? Like any specific question or just domain and range in general?
just like domain and range in general.
So, okay, let me. Okay. So, okay. So if I'm looking at a table, all right, and I say, let's say I get -1, 2, 0, 4, 3, 5, 4, -1. All right. So -1, 2, 0, 4, 3, 5. Okay. So looking at this, the domain is going to be all real. I mean, not all reals, I'm sorry. The domain is just these X values right here. This is the domain, and then this is the range. So when you're looking at a set of numbers, the domain is all the possible X values that can be on the graph, and the range is all the possible Y values that can be on a graph. So what I think gets confusing is that when you have a graph like this, and you see a line like this, the difference here is that the domain and range is all reals. And because there's arrows right here saying that this graph goes on forever in that direction, this graph goes over forever in this direction, there's no limit to the X's and Y's that you can have. So the domain and range. Whereas here on this graph, you are limited with your domain and range. So the domain is just the values for the X and the range is just the values for the Y's.
Okay.
Okay. Now, the other thing that gets a little bit confusing is when you add another kind of graph. Let's see, something like this. Right. And so in this one, you had just very limited number, just those 4 domains. Here you have all reals. So that's a pretty wide span. Well, here you have more than you did with the first one. Okay, like here's number 1, here's number 2, here's number 3. You have a wider domain here because here in 1, you only had these 4 numbers, but you still don't have as many as you do in option 2 where you've got unlimited domain. So something like this one, the domain would be like, let's say this goes from 1 and this is 5. This is where you would say 1 is less than or equal to X, which is less than or equal to 5. That would be the domain. So these are the 3 possible ways that you're going to see the domain.
Oh, okay.
Does that help or?
Yeah. Also, hold up. Like, also for like in number 22, stuff like we did it in class and everything, but I mean, I really don't get it too much.
Okay.
So.
All right. So, okay. Okay. So here, so let's say I'll start off with 0 first. All right, so that means that f of 0, and I know 0 is not one of them, but just to kind of make the point. Okay,
Yeah.
so f of 0 is 2/3 of 0 plus 4, which gives you 4. And so this means when x is 0, y is 4. Okay, this is just a fancy way of saying when f of 0, that f of 0 equals 4. So you're just saying, here's your x and here's your y. So when you see function notation like this, don't let
Wait,
it.
but hold up.
Okay.
How? Okay, never mind. I got it.
You want me to keep going?
Yes.
Okay. All right. So then let's plug in. I'll plug in 3. I'll do 3 next. So f of 3 is 2/3 of 3 plus 4. So remember, 2/3 of 3 means 2/3 times 3 over 1, which is 6 over 3, because you just multiply straight across, which simplifies to 2. And so this is 2 plus 4, which is 6. All right, so when x is 3, y is 6. So 3 comma 6 is the point, which is the same thing as saying f of 3 equals 6. And there's nothing for you to do with the f of 3. It's just another way of saying a function of 3.
Yeah.
Okay. And so then I'll do it with the -6. So if I have f of -6 is 2/3 of -6 plus 4. Which is -4. And then -4 plus 4 is 0. So the point is -6, comma 0. So -6, comma 0, which means f of -6 equals 0.
Okay, yeah, gotcha.
And so what I think, like earlier today on Delta Math, like here, let me just make one problem up. All right, so let's say this is the point -1 comma 2, and then let's say this is the point 2 comma 0, okay?
Mm-hmm.
What is f of -1?
Wait, what do you mean? So, like, can you ask that again?
Yeah, so what is f of -1 using the graph I've got on the screen?
2?
Very good, it's 2. Because all this means is this just means when x equals -1, what does y equal?
Oh.
Okay, so, but what if I say something else? What if I say f of x equals 0?
Mm-hmm.
What is x?
0?
Nope. It's going to be 2.
2. Oh, wait, no, okay.
Because this is the same.
No,
Yeah,
I
this
didn't.
is yeah, this is the same thing as saying y equals 0. Well, if y equals 0,
Yeah.
then x equals 2. So that kind of ties in with this right here, is just knowing what you're plugging in and getting.
Oh, okay. Well, yeah, that was really it.
That's all you got?
Actually, hold up. Can you remind me what dependent and independent variable is like?
Definitely. All right, so an independent variable is going to be the x variable, and the dependent is going to be y.
Yeah.
Okay, so if you are going, okay, let's say you go to an amusement park and you have to pay $2 per ride. Okay.
Okay.
Is the total cost that you pay, is that dependent on how many rides you take, or is how many rides you take dependent on the total cost you pay?
So the cost is dependent on how much rides you.
Perfect. Exactly it. Right. So the total cost, and usually total cost or total time or something, the total cost is going to be dependent on the number of rides that you take.
Okay.
Okay. And if you think about it too, if you ever get stuck, think about when you graph it. Like you're going to graph the number of rides on the x-axis and you're going to graph the cost on the y. That kind of helps too when you're doing it.
Yeah.
And then I also will ask myself, like I just asked you, is total money dependent on rides, or is rides dependent on money? Like which way makes more sense? And that makes it more obvious too.
Okay. Yeah. Also, can we on number 15?
Yep, definitely. Did I just pass that? Yes, I did. Oops. Oh, okay. All right, so this one, so a school secretary is buying pencils. They come in packs of 10. Show if she had enough money to buy 1, 2, 3, or 4 boxes. So she buys one box, that's going to be 10 pencils because they come in boxes of 10. So 2 boxes is going to be 20 pencils. 3 boxes is 30, 4 boxes is 40. And that's all I'm going to graph because that's all that was listed here in the domain. So because it is a limited domain and it's only those numbers, this is discrete. I'm not connecting the dots. Okay, so discrete is dots, and they're the ones where you're saying, because like if I connected these, then I'm saying that I could buy, or she could buy 2.5 boxes of pencils. Well, she can't do that. She can only buy, right? So that's the difference between discrete and continuous. So here, oh, go ahead.
How do you know like when to connect and not to connect?
So if it gives it to you like this, where it just tells you that these are the only numbers in the domain, do not connect them.
Okay. So if it doesn't give you like the domain, then do you connect?
Yes. So let me see. I know there was an example on that study guide right here on the screen. All right. So 23, this is a limited domain. So this would be a discrete graph. You would just have dots here. Whereas here, no domain was given. And so you could plug in anything.
Okay.
And so, so this would be continuous because then you could connect the dots and you could say that all those fractions and decimals in between are part of it.
Okay.
Okay.
So wait, and there where you were on 24?
Oh, yeah.
Would you like, how do you graph that? Because like X with the
right. So if you're not given one, if you're not given the domain, like here, you could just plug in those numbers and get your domain, right? I mean, get your values to graph. Well, here you're going to have to come up with your own. That's terrible. You're going to have to come up with your own. And so I would suggest doing -2, -1, 0, 1, and 2, just so you have some negative and positive numbers. And you're just going to plug them in. Like, so you'll just plug them into this equation here and you get them. But the difference is that you're going to connect them because it didn't tell you you had to use these. You're just using these just to get an idea of what the graph looks like.
Okay.
So, so you would do -2 squared, which is 4. 4 minus 3 is 1. 1 squared is 1, minus 3 is -2. 0 squared minus 3 is -3, and so on. And then you would just get your points, and then these you would connect.
Okay. So, like that one you just did?
Uh-huh.
So you just subtracted 3?
Well, I squared it and subtracted 3.
Okay, yeah. Okay.
Yeah. Yep.
Yeah. And same goes for number 23, but with the domains you're given?
Correct. You have to use those.
Oh, okay. Yeah. And then I think I got one more on 16. 16, yeah. Where it says the notation.
Okay. So if X represents the number of days that you're going to park, and Y represents the total amount of money that you're going to pay. So parking is available for $8 a day. So you're going to pay $8 per day that you're there. But function notation is just saying to use f of x. So you would say f of x equals 8x. It's just telling you that this is a function of x. Like the amount you pay is a function or dependent on how many days you are at the airport parking.
Oh, okay.
So going back to your previous question, the x would be the number of days that you're at the parking lot. That would be your independent variable, and the total cost that you pay, that would be the dependent variable.
Okay. In the test, is there gonna be any like that? But you know, where like, aren't there some like that are instead of f of x, where
There'll be some that'll say why.
yeah, why? Okay,
Yeah, there will be some that will say why.
okay. And how would you do that? Like why?
It's the same. I mean, it's just the same. They're used, y and f of
Just
x are
y
just
instead of f of x?
It's
Oh,
kind of like your study guide, like right here. It just said like, so a swim pass costs $30 each month. What would be the equation? You would just say y equals 30x.
30x. Okay.
But if I said use function notation, you would say f of x
X
equals
equals
30x.
30. Okay. And then for number 2 and 3, it's the same
Right.
thing.
Yep. Well, what do you think the independent variable is now?
Um,
So x is the number of months and y is the total amount you're paying.
$30, right?
Right.
Okay. Okay, well, yeah, I think
Wait, what do you think is the independent variable?
the independent would be for number 2,
Yep.
um, the months,
The
like the
months.
time.
And then the y would be the dependent variable, the total cost that you're going to pay.
Okay. Yeah.
That would be dependent. Okay.
All right. Well, I think that's it. I mean, I understand everything now.
You sure?
Hold up. I'm looking at that.
Hey, London.
Yeah, yeah, I'm pretty good with everything
Pretty
else.
good.
Yeah.
Okay. Well,
All right.
if you think of something else, you can email me questions. Okay.
Okay. Thank you.
All right. All right. No problem. Bye.
Bye.
Hey, London. Can you hear me? Do you have any questions that you want me to go over? Okay. And you can turn your microphone too if you prefer to talk, or you can type. It's up to you. Yep, definitely. Okay. All right, so for this one, The graph starts here and it goes this way. I think it was like that on yours before we made copies. So for the domain, so this is your x-axis, and so all your possible x values are listed this way. Well, the graph cuts off here. So for domain, we are going to say that x is greater than or equal to 2, because there is a value here at 2, but there's nothing else over here past that. So that's why all your x values are this way. We're going to say x is greater than or equal to 2. Now for your range, this is the lowest y value right here. And this is y equals 0. So the range never dips below this because the graph is going this way, meaning everything's up above. So we're going to say that y is greater than or equal to 0. All right. And then as far as increasing and decreasing, you're looking at the y values. And so this graph, this is going up. I know it's not going up much, but it is going up. It's increasing. So we're going to say that this graph is always increasing because it's never decreasing. I don't know what I'm writing. Always increasing. The graph does not have a maximum because it's going up this way. So because it's keeps going up, we don't know what the maximum is, or there isn't really a maximum, it's just going up. But the minimum is down here because that's where it stops. Like it starts there basically and goes this way. So because it doesn't go past that, we're going to say that there is no max, but the minimum is at y equals 0. So the minimum is the lowest y value. The x-intercept is where it crosses the x-axis. So this graph crosses the x-axis here, which is at 2, and it does not cross the y-axis here at all. So for y-intercept, we say none. On the left, for the end behavior on the left, we're going to ignore that part. But on the right, because it's going up, we are going to say that that rises. Did that help, or still questions about it? Okay. Well, you were easy. If you think of something else, email me or let me know.